Okay, so I didn't actually have colored pencils. I've got these hilarious candy-scented twistable crayons. So that's what I'm going to be using today. I've got my ruler, I've got my protractor, and I've got my notes sheet. So the first thing we're asked to do is to just look at these different figures and look at the reflection symmetry that's detailed in each one. And so reflection symmetry is kind of the classic type of symmetry you think of when you've kind of encountered symmetry throughout your school careers. So the idea with symmetry is that it is like perfectly lined up on either side. And so if I took this figure and I cut it out and then I went along this line here, then I would be able to like cut it out and kind of fold it over onto itself, and it would look exactly the same. And so I would see that I have a line of symmetry here. You guys are gonna have to forgive my drawing, it's not gonna be perfect. On this sheet, I have a line of symmetry here, and I actually have a second line of symmetry. And then on this guy, I have 1, 2, 3, 4 different lines of symmetry. So if you want to count the number of lines of symmetry, it actually can be tricky with these that go all the way around, because it's easy to make this mistake of counting and going, oh, there's 1, 2, 3, 4, 5, 6, 7, 8 lines, right? But if you counted that way, you would actually be over counting. So here's 1, 2, 3, 4, and if I want to say this is the 5th line, I kind of don't notice that this is the same line here. So there are only 4 lines of symmetry here. So take a moment and see if you can draw in the lines of symmetry for this figure. So I hope you do that on your own, but I'm going to go ahead and do it, and I'm going to try to do it without my ruler and just hope it's not too sloppy. So I'm going to kind of mentally cut these cups in half to draw some lines of symmetry. Oh, that could have gone better. And here's another one. Okay. So I found 1, 2, 3 lines of symmetry here, but I think there are actually more lines of symmetry. I think I could also like segregate. There's like 3 cups there and 3 cups there. I don't know if these are really cups. It's just kind of what I imagine when I look at them. So there's another one there, and another one here, and another one here. Okay, so how many lines of symmetry do I have? 1, 2, 3, 4, 5, 6. And if I went here and wanted to say 7, well, that'd be recounting the one I already had. So 6 lines of symmetry in this little figure. Then if we look at this figure, go ahead and give it a try and see how many lines of symmetry you can find. And then I'm gonna see if my twisty crayon is ready. Look at those eyeballs. Okay, so drawing in my line of symmetry, here's 1, here's 2, 3, 4. That's great, but I actually think I can't just split these things. I could also like draw lines between the hills. Oh, there's gonna be a lot here. All right, so that's 1, 2, 3, 4, 5, 6, 7, 8 lines of symmetry on this guy. All right, so the next kind of idea in here is the frieze pattern. These frieze patterns, yes, we just have a certain stretch of them along here, but actually a frieze pattern you would imagine would be going on forever and ever. And so we can have horizontal or and or vertical symmetry. And so just to remember, pretty important to remember this actually, that horizontal is the one that's like the horizon that stretches across. So this frieze pattern only has horizontal symmetry. If I tried to find symmetry in a vertical way, these things wouldn't line up exactly. And then on this next one, I see that I have some vertical symmetry, because I can imagine, as long as I'm imagining that this thing goes on forever each way, I have all of these lines of symmetry that are like splitting this thing in half, right? Imagining that this would just layer on because it's going forever each way. And so I could have as many of these lines of symmetry as I wanted that kind of cut this thing through. And then I have as many of these kinds of symmetries I want, which is like cutting these in half. And so I have infinitely many lines of symmetry, but I actually have like infinitely many of this type, the blue type, and infinitely many of the red type. Okay, but then if I tried to find a horizontal line of symmetry, it's not going to happen because this thing is, however I want to imagine or talk about it, like this thing is more top heavy than the bottom. If I tried to flip it onto itself horizontally, it wouldn't work. And so if I look at this frieze pattern, I'm going to use the same color just to kind of keep it in my mind. It looks like if I go and look for a horizontal line of symmetry, I can find one. And if I'm going to look for a vertical line of symmetry, I could find a vertical line of symmetry where I'm kind of like between these shapes. If I want to think of it as a, I don't know, 4-leaf clover or something. So I have infinitely many that are along here. And I think I even have another line of symmetry where I'm looking at the middle here. So this entire worksheet is looking at reflection symmetry and further like finding lines of symmetry, where the line of symmetry is where if you took that line and kind of like fold over the line, then you're going to have something that matches up exactly on either side. Now on the other side of your worksheet, I think it's other side or it might be the next sheet, is where we're looking at recognizing rotation symmetry. Now rotation symmetry is a little different because rotation is not looking for just a single line of symmetry. It is looking for something to spin around and look exactly the same. So not that we're folding over, but we're spinning it around to look exactly the same. So here we have some kind of triangle business. And with this triangle business, we see that there's noted 120. And I think if I was being picky here, I'd really kind of want this to say 120 like degrees and have that degrees symbol there. So the angle of rotation is called 120 degrees. So I think there are a couple of ways that we come to that 120 degrees. One way would be to directly measure it. So you could get out your protractor and go to measure it. Now, if you remember from other times in your life when you've used a protractor, sometimes the lines aren't long enough as is, so we have to imagine extending the lines forever, and we could even go in with a pencil and extend this line up. If I extend it straight up, it's going to come and line up here to the 120 or the 60. Now, if we have to choose between 120 and 60, well, we look at this angle and we see that it's greater than 90 degrees. And since it's greater than 90 degrees, we know this is going to be an angle measurement that's greater than 90 degrees. It's going to be 120 degrees. So one way to test this would be to directly measure it. Now, another way that we could test this would be to remember that on the inside of any circle, that all the way around that entire circle would be 360 degrees. So if all the way around that entire circle is 360 degrees, and then we see that there are 1, 2, 3 equal-sized portions, then we can take the 360 degrees and divide by 3 and see that it would be 120 degrees. And as we would hope and expect, both of those methods for finding the answer are going to be the same. So here I have something that's kind of a pentagon shape. I've got 5 equal inner angles the same. So I could go and measure that. Once I get to 72 degrees, that's harder to get an exact measurement on. And so I might again want to go, if I know the entire thing is 360 and I've got 5 equal-sized pieces, I've got to do the 360 divided by 5. And then finally I come over here and I see 1, 2, 3, 4, 5, 6, 7, 8 equal-sized pieces. If I have these 8 equal-sized pieces, the 360 divided by 8 is going to get me to that angle of rotation of 45 degrees. I have an additional video on angle of rotation. This tends to be a hard concept, so please make sure you check out the other video as well to make sure you're really understanding this. So I'm asked here to draw and determine the angle of rotation on this figure. So take a moment and see if you can figure it out yourself first. then I'll go ahead and look at what I'm seeing. I notice that I kind of have this interesting square-ish shape along here. And it seems to me that if I took this, you know what, I'm even gonna do it. If I spin this around, if I spin and I spin like this, it looks exactly the same again. And I spin like this, it looks exactly the same again. And spin around again and again. And so it really does matter that I am truly rotating this figure to see what's going on. So if I need to determine, so I drew the angles of rotation, and now I need to determine the angle of rotation. So I see inside here, now I look at that shape, and it's a very pleasing shape. I've seen it many times in my life. I see that this is a right angle, right? And so I know this is a 90-degree angle. But I could also go and say, well, the entire interior is 360, so 360 divided by these 4 equal-sized chunks is going to get me to the 90. And then one more here. I look at this kind of shape. I hope you do this on your own first. I look at these little things. 1, 2, 3, 4, 5, 6. Okay, 6 equal pieces. And then 360 divided by 6. The angle of rotation here is 60 degrees. Now notice, this is rotation symmetry. This is rotation symmetry. I am not claiming that this is a line of symmetry here, like the reflection symmetry. This is not a line of symmetry, because if I tried to flop this onto itself, it's not going to add up exactly. It's not going to be exactly even. So I'm not claiming it is a line of symmetry. I found an angle of symmetry for rotational symmetry. All right, so how can you determine how many rotations there are? What formula helps you find the angles of rotation? I would encourage you to think about what formula helps you find those angles of rotation. What have we just discovered? And then finally, freeze patterns. So I'm going to leave this as an open question that you're going to want to come to as you're doing your homework. You want to think through how you would answer that question. All right, so at the end it's saying freeze patterns can have rotation symmetry, but only rotation symmetry is possible if it's 180 degrees. So if I think about 360 degrees is if I turn this page, okay, let's just do it. 360 degrees would be if I start here, I turn all the way around to get back to 360 degrees. So 180 degrees is if I take this paper and I turn it just to be upside down. I've gone halfway around the full rotation. If it looks exactly the same, then I'm in good shape. I have my rotational symmetry. So let's look at this one, this shape here. I'm looking at it right side up. I'm looking at it upside down. Does that have rotational symmetry? Sure looks the same to me. So this one, yes, has 180 degree rotation. Oh, this crayon is not giving me the prettiest handwriting. Okay, now let's look at this guy. Now this one, I want to be real careful as I look at this one. I'm kind of looking at this shape. I notice it's got this like check mark up in the upper right, and a check mark in the kind of lower left. So let's turn it upside down and see if it looks the same. Oh, I see, whoops. Check mark in the upper right, check mark in the lower left. It looks to me like yes, this freeze pattern down here also has this lovely 180 degree rotational symmetry. I'm not even gonna finish writing that because it wasn't looking pretty, but it has this symmetry. So it's actually really important, like the question, does this shape have symmetry? Like that is way too broad a question if we're going to dig into these ideas. We can look at this pattern and it does not have all the symmetry like from the page before. If we were looking for the reflection symmetry, we're going to be kind of in trouble looking for reflection symmetry here. But it does have the rotational symmetry. So in this video, we went through and looked at reflection symmetry, where we had those lines of symmetry that we could find. And we looked at rotational symmetry, where we could find the angles of symmetry. And then in your homework, you are going to be practicing finding different types of symmetry. All right.